Hello, this is Mr. Best. Welcome to Chapter 7, Homework Questions 35 through 41. Question 35. Your banker shows you the graph at the right to explain what you can learn if you invest with him. Does this graph represent simple or compound interest? How can you tell? Write an equation to represent how much money you would have as time passes. Make sure you write let statements. Alright, so the first thing is we see that the graph is linear, so that's going to tell us from what we had learned that this is simple interest. So the first part of this question, we do know this is going to be simple interest, which means you're gaining a certain percent based on the original amount that you received. So that's how, kind of the next question, how can you tell that? As we said, it's based on the original. You're just gaining that same percent each year from the original. Write an equation to represent how much money you would have as time passes. So it does tell us to write some let statements here. So let's go ahead and do that. We want to say let, and we'll just do x as our number of years. So let x equal the time in years. And then we can also let y equal the money that we have in the bank, it says, yeah. And so now write the equation to represent how much money you would have as time passes. And if a table helps you see that, then create a table at time 0. It looks like we're starting at $500, so that's right here. And then for every year, you're going up $100 for every 1 year. So the next year, you're at $600. The next year, you're at $700. So you can see that you're increasing each year by $100. All right, so you're only gaining that interest because it is simple interest on the original amount each year. And so it wants us to write an equation to represent how much money you would have as time passes. So y is equal to, we have our initial of $500 plus $100 each year is added to what we have. And so I think then that answers all of the questions. So we wrote the equation. We said it is simple interest. And we kind of explained and wrote our let statements as well. Question 36. Each table below represents an exponential function in y equals a times b raised to the x form. Copy and complete each table on your paper and find a corresponding equation. So we need to know what the initial is and we need to know what the multiplier is. So on table A, we don't know what the initial is because that's at x equals 0. We don't know what the multiplier is because it's not given, and we're missing a value right here. But we know 3 times b will give us that value, and then that value times b will give us 75. So let's use that to help us identify what the multiplier is. So 3 times b should equal 75. So we can divide by 3, and that gives us b times b, or b squared, is equal to 25. And then what number times itself gives you 25? B would be equal to 5. So now we have the multiplier, and now we can just multiply 3 times 5 to get the value. So we'll take this b away, and we'll change it to a 5. So 3 times 5 is 15. 15 times 5 is 75. And then we'll just keep going and multiplying by 5s. So 75 times 5 is 375, and 375 times 5 is 1,875. So we've completed the table. We have the information to write the equation, so now let's write the equation. Y equals the initial value of 15 times the multiplier of 5, and since that just happens over and over again, we raise it to the x power. On part B, once again, you're given the table. You, once again, do not have the initial, and you don't have the multiplier, but we can figure that out. This time we have back-to-back numbers here, so it'll be 96.64 times B should equal 77.312. So we'll divide both sides by 96.64 to find our B value. and that gives us a B value of 0.8. So now we know that. We can take the 77.312 and multiply by 0.8 to find the next term in the table, which would be 61.8496. That's exactly what it is. We could round, but I wrote the exact value. And then now we need to work backwards. So if I want to know what this y value is, then I need to take y times my b, which is 0.8, to get 96.64. So think about that. That's going to be y times 0.8 should give me a value of 96.64. So to solve for y, we divide by 0.8. Also realize that if you're working down and multiplying, then to find the values before that, you need to divide. So 96.64 divided by 0.8 will give us 120.8. So I'm going to take this y out and write it as 120.8 for x equals 1. And then you can take 120.8, divide it by 0.8 again, and you'll get 151. So there's your initial. You have your multiplier as well. So now we can write the equation. Y equals the initial of 151 times your multiplier, which is 0.8 raised to the x power. And so that's how you can write an exponential equation given a table. Question 37. Tickets for a concert have been in incredibly high demand, and as of the date for the concert draws closer, the price of the tickets increase exponentially. The cost of a pair of tickets was $150 yesterday, and today it's $162. As you complete parts A through C below, assume that each day's percent increase from the day before is the same. So on part A, it says, what is the daily rate of increase? What is the multiplier? So what we can look at is the cost of a pair of tickets was $150 yesterday. We can treat that as our initial. So initially they're $150. On the next day they go up to $162. So what is the percent increase, and then what is the multiplier? So we can find the multiplier by asking ourselves what times 150 will give us 162. So 150 times B is 162. So therefore, if we divide 162 by 150, that'll give us the multiplier of 1.08. So the multiplier is 1.08, but the percent increase, because 1.08 as a percent is 108%. But remember, we start with 100%, so the percent increase is the 8%. So there you can see I wrote the answer in terms of what the percent increase was and what the multiplier is. Part B, what will be the cost of a pair of concert tickets 1 week from now? So as we look at this question, we can use part A to help us with this. We could actually continue the table out from a week from now, or we can write our equation knowing that y is equal to the initial value of $150 times the multiplier of 1.08 raised to the x power. Now when you read this question, 1 week from now, or 1 week, would be 7 days. So we're inclined to take 150 times 1.08 and raise it to the 7th power. But it does say 1 week from now being 162. So technically, if we were starting at the initial of $150, then it would be a 7. But since we're actually starting from now, which is day 1, we need to add that extra day on. So it's actually y equals 150 times 1.08 raised to the 8th power. And once again, I want to be clear on that, is that it's 8 because it says 1 week from now being today at $162. So we're already 1 day in, so add another 7 to that and we get 8. And if we plug that in, we get $277.64. So what will be the cost of a pair of tickets 1 week from today? Right there. Part C. What was the cost of a pair of tickets 2 weeks ago today? So kind of the same ideas. We're going to start with our equation. 2 weeks ago, would be negative 14 because we're going backwards. But if it's still including where we're starting, which is now, we add that 1 day that we started. So really it's y equals 150 times 1.08 raised to the negative 13th power. And if you plug that in, you'll get a value of $55.15. So that's how much it would cost if we bought them 2 weeks ago, if this model still was a good model in terms of it increasing exponentially like it is by that 8%. Question 38. Dusty won $125,000 on the Who Wants to Be a Zillionaire game show. He decides to place the money into an account that earns 6.25% interest compounded annually and plans not to use any of it until he retires. Write an expression that represents how much money Dusty will have in T years. So on part A, we need to know what is that initial value. Well, he won $125,000. We're going to say that, we don't have to worry about money being taken out in taxes. So that's what he started with. The multiplier, you started 100%, and it's gaining interest at 6.25%. So that's 106.25%. And then you divide that by 100 to get 1.0625. This would be your multiplier. And so since we have both of those things, we can write an expression. It doesn't say write an equation. It does say write an expression that represents how much money Dusty will have in T years. So if we're just writing an expression, that would be our 125,000, which is our initial, times the multiplier of 1.0625. And instead of raising it to the x, it says use T for years. So raised to the T power. And that represents an expression, not an equation. If we wrote it as an equation, we would just say y equals. So there's the answer to part A. Part B, how much money will be in the account when he retires in 23 years? So now we'll write it as an equation. Y is equal to 125,000 times 1.0625, and then raised to the 23 because of the number of years. And remember, this is compounded annually, so that interest that you are gaining is off the original 125,000 plus any interest that was gained. So it is this exponential equation that we're looking at. So go ahead and plug that into your calculator. And in 23 years, the 125,000 would have changed into $504,052.30. So that's how much he would make when he retires. And so make sure you finish off that question by answering it and using the dollar symbol. Question 39. The winning times for various swim meets at Smallville High School were compared to the height of the swimmer. The residual is shown at the right. Sketch what original scatter plot might have looked like, So the residual is on the right. You can see height is your x, so I got height in centimeters as my x. The residual, for the residual plot is in seconds though, so that represents my time in seconds on my scatter plot. And so remember what I'm going to do here. This distance is how far it is from the least squared regression line. So I'm just going to plot the points and try to make it look as accurate. Put these points at the beginning a little bit farther away from the least squared regression line, and then as you get to the end, the points are going to be a little bit closer. So there's the scatter plot that I have drawn out. It doesn't have to be exact. You can actually have different y-intercepts. You can even have a different slope. Your slope could even be negative. The big thing is that the x-coordinates and the position of the points relative to each other are precise based on your residual plot. So that was A. Part B. What does the residual plot tell you about predictions made for swimmers that are shorter compared to swimmers that are taller? So you can see on your residual plot, as the height of the swimmers get taller, then the least squared regression line is more accurate, and so the model made predictions that were closer to the actual values for taller swimmers. And I went ahead and wrote that on the bottom there. Question 40. Solve the following systems of equations. So this will be good practice on solving systems again. On the first one we have 3x minus 2y equals 14 and negative 2x plus 2y equals negative 10. Now this one's set up pretty nicely for us. It has the x and y's on the same side. So you can just add them and the y's eliminate as well. So you get x, the negative 2y plus 2y cancel and eliminate, give you 0. And then 14 minus 10 is 4. And we don't have to divide, so x is equal to 4. We can then take the x equals 4 and plug that back into one of the two original and then solve from there. 12 minus 2y equals 14. Subtract the 12 to get 2. Divide by negative 2. Y is equal to negative 1. So our solution is 4, negative 1. On B, this one is set up for substitution because your first equation is y equals 5x plus 3. So we're going to take the second equation and replace the y value with 5x plus 3. Make sure on the next part here it is negative 4 times the quantity, so it's negative 4 times 5, which is minus 20x, negative 4 times 3, which is negative 12. So we'll combine our like terms, add the 12 to the other side, and then divide by negative 22. So we get x equals negative 1. Once again, we'll plug that back into one of our two equations. And I plugged it back into the top one with y equals, so it looks like I'll get y equals negative 2. So negative 1 comma negative 2 is the solution. And remember, we can plug these back into both equations and check that our solutions are correct. On part C, it says, which system above is most efficiently solved by using the substitution method and explain? And I really already did that while I was going through. So on part C, which system above is most efficiently solved using the substitution? We would say question B, and you need to write down in terms of what we already talked about that the y is solved for. And then on D, it wants to know the elimination method. And once again, for that one, as we had already spoke about, or I had, that would be question A, and that's because you have your x and y's on the same side and it's equal to the constant. Question 41. If you flip a fair coin, that is, what is the probability that it comes up heads? And what is the probability that it comes up tails? Well, there's only two possible outcomes when you flip a coin. It's either going to land on heads or it's going to land on tails. So, you only have two possibilities, and if it's going to land on heads, then it's going to happen one possible time out of two choices. Tails is the same way. There's only one possibility out of two choices. So typically the way this is written, if you've done probability before, is we write P, and that stands for probability of landing on heads, is equal to 1/2, and then the probability landing on tails is equal to 1/2. So once again, 1 represents your favorable outcome, which means it just means that there's one possibility, and then the 2 represents how many possibilities that you have in terms of flipping that coin. So that's what it's asking.